Okay, so I solved 6 problems. The sixth one, 5 minutes after the contest. So yeah, let's go through them. So problem A. Okay, so here we are given a string S, and we only have to filter out the digits from that string. So, like simple implementation idea, you take string input, like depending on your language, if you're coding in C++, like you can iterate over each character. If it is a digit, then you can check if it is between 0 and 9 character. In that case, you can just print that value. So the way I have done it is like I split the string into characters and I filtered if they are numeric, like if they're digits. So this also works. And yeah, going to problem B. So here we are given n people and each person send gift to some people. So we have to tell for each person how many from which friends they have received gifts. So if we see example, the first person gives it to sends one gift to second person. Here the second person sends one gift to third person. Third one sends one gift to second person, and fourth one sends three gifts to each of 1, 2, and 3. So accordingly, how much they have received and from whom they have received, you have to maintain that. So we can just maintain of like an array, a vector here, and then accordingly, like I iterate over each person. They send k gifts, so I iterate over them. For each gift, like to whom each person they're sending, I take that input and I push that in the answer. So if we see this, let's say the first person sends one gift to person 2. So here A will be 2. So use zero index idea. I push in answer of A minus 1. I push I, which is a current person. So who sent the gift? So that is what we have asked. So when we will iterate over this, we will have this one here. Yeah, then we just iterate over the answer and the values accordingly as asked. So this is the second one. Going to the third one. Okay, so here we are given some intervals, and it is guaranteed that the x and y coordinates are permutations. I'm not sure if that helps us, but yeah. So what? So we have asked for each point if if it contains some point inside it. Like if we see this here, if we have some xy, so this is like a rectangle from 0, 0. If it does not contain any point in this region, then it is a good point, let's say. So we have to tell the number of good points here. So if we see this example, I must have drawn it here. So it is 2, 1, 1, 3, and 3, 2. So these two are good points, but if we see this one, this contains this point, so uh, it is not a good point. So these two will contribute to our answer. So the way I have solved it is, if we see this observation, like I try to, uh, if I have some point here, let's say, then this is not going to bother us, right? So I iterate over increasing values of x and y. So if I see the implementation, if we go through this, we sort these points, and I maintain the minimum y we have encountered till now. So again, if we are at some this point, we have encountered all the points that occur in this x range. So we maintain their y values. Let's say this was the scenario. So the minimum y value is what we care about, because let's say the minimum y was this, like these 3 points were there, and the minimum y is this, which is greater than our current y. Then this is a good point. This no blocker is there for this. So like that is the idea. We sort the points, maintain the answer, and maintain the current minimum y across all the points. Then we iterate over them, and If y is less than the minimum y we have encountered so far, then this point will increase. This point will be included in our answer, and we update the minimum y as well. One more thing to note here, that if we have some scenario like this, 2 points having same x values, then I believe this counts inside, so this is not a good point. So the way I have so we have to note that in sorting we cannot only sort on basis of x, but this sorts on basis of both x and y. So this will come first, this will come second. Just a point to note, because that I believe that might create some problems. Like if we encountered this first, then we have not seen this point, then it will consider that as an answer which is wrong. So yeah, that is problem C. Problem D. Okay, so here we are given like n intervals, n people, and the time intervals they are inside the mansion, and we have to tell the number of time segments we can consider of d length, such that at least two people are there. Like uh, the combination of a time segment and the two people in that can be there in a mansion. Okay, so if we like see this example, uh, the gap is 2 and these are the intervals, there are 3 people. So from this interval 9 to 17, 10 to 12, uh, so if we start from 10, so from 10 to 12 is there a time interval in which this is there. But if we see this, sorry, the first and the second one, then we start from 13 to 14, that will be a time interval. 14 to 15 of sorry of 13 to 15 and 14 to 16 are also a time interval that is contained with both ranges, and so is the same case 15 to 17. So they're all counted differently. Yeah, as given here, time 13 to 15, 14 to 16, and 15 to 17, all of them are counted individually. So the way I have done it is like, the good thing is that on start and end time there are constraints of 10 power 6. So I can iterate over each time period. I iterate over all the possible values of x, and then I check in this x to x plus d interval how many people are there. And then if there are, let's say, y people from x to x plus d in this range, if y people are present in the mansion, then we choose yc two ways. Then we have yc two ways to choose the people. So that is what I've done here. And to maintain the number of people, I'll go through that logic later. So let's just say we have intervals here. I iterate over x from 1 to m minus d. Like m is the maximum value we have. I'll go to the implementation this idea. But yeah, for we iterate over each value of x, and then this current is the y here, the number of people. Then we choose current C2. Now, how to find this y? So the way I have thought it was like, if we have some intervals, right? So if we sort those intervals, so here I have sorted the intervals, and I have found uh, I have sorted the intervals, and for each x, let's say this is like a timeline from 0 to 10 power 6 or something, and we are at point x. So till now, I have added all the points that start, all the intervals that start with x. Some can be like this, some can be like this, some can be like this, and x plus d is here. So here I store the frequency of all the end points, end times in a Fenwick tree. Okay, so let me just say, Fenwick tree we can later. So let's say we have three intervals here. So let's say this is 1, 2, 4, 10 power 6. Let's say. So we insert 2, 4, and 10 power 6 in our array. Let's say we maintain an array, we maintain a collection, and we store these three values. And now let's say x was 3 and x plus d was 5. So we only care about those intervals that occur. Let me just draw one more here. this one. So, and this is, let's say, 7. So we have 7 as well. So we only care about intervals that are in that con that are that in includes the entire is 3 to 5. This 3 to 4 will not work, and 3 to 2 already end before it began. So I added all the intervals before 3, and I'll count the values which are greater than equal to 5, which is 2 here. So this will be our y, and then we choose yc2 equal to uh, 1 way. Now, how for that, for finding these values, I've maintained a Fenwick tree. Like if you don't know, you can store some sort of prefix sum of and prefix sum, and you can update and query it efficiently. So I'm not going into too much detail of what is a Fenwick tree, but yeah, if you see the implementation, I start with x and I sort the intervals, and for all intervals whose x axis whose start is less than x, I add them to the interval. I add their end time to the end time in the Fenwick tree, and then I count the frequency. This is like the entire length of elements I have considered so far, and this is the like the number of elements which are not sufficient, like which come in this range. So I've subtracted this minus this, the larger minus smaller here, to get this value. So I get the number of elements that satisfy a property. So yeah, that is problem D. Problem E. Okay, yeah, alternating cost. So here we are given a grid, and we have given some movements, and their cost is according to the parity of the movement, like for which step we are on. So the way I have solved it is like we have to go from 0, 0 to xy. So let me open it. Yeah. So let's say we have to go from 0, 0 to xy. Right. So we have to make x horizontal movements plus y vertical movements. So for now, consider that both x and y are like positive. So we have to move both. Uh, like in this problem, we are given x and y as negative as well. But if we realize, since we only care about parity, and the movements are like we can move one horizontal step with cost A and one vertical step with cost B, the sign doesn't matter here. So if we see the implementation, I have already taken their absolute values of x and y. Okay. Coming back to idea, we make x horizontal movements and y vertical movements. Now, if we have to make both the movements, then it is better, like let's say we start from here and we have to go some here, someplace here. So let's say this, uh, yeah, this is, let's say, x y, and I'm assuming that x is greater than y for this one. So x y, uh, yeah, okay, this is y, this is x, this is y. So let's say this square, in this, irrespective, I can start moving like this or I can start moving like this. In both cases, I will make y horizontal movements and y vertical movements in any order I want in the alternating fashion. I can start with like horizontal, vertical, or I can start in the opposite way. So in both the cases, I can choose the minimum value of a and b for these two y movements. I will have two y movements, y horizontal and y vertical, to reach here. So that is what I've written here. If m is the minimum of xy, so in the minimum cost of AB, and I'll have two m steps, and then I'll reach m comma m, then I have to go from x comma y. This will be like a one-dimensional movement. So it will be either horizontal or vertical. So in this case, it is horizontal, as I explained. So now coming to idea, let's say assume I am having a vertical movement here. Then how to solve it? So yeah, that is, I have considered some scenarios that I can travel. Either I can travel directly straight here. So in that case, the cost will be C. If let's say y is the, like d is equal to y is here. So it will be CL of d by 2 times b, plus floor of d by 2 times a. Other set of movement we can have is like this zigzag movement, or we can start from top right or something. So here we start from horizontal to vertical, and we start from vertical to horizontal. So this is like the cost. If I see the code, this is like the cost we are going to face if we start from horizontal then vertical, and this is the cost if we start from vertical then horizontal. So I take minimum of all of these, and that I add it into our answer. So if we see just one thing in the implementation, uh, if uh, I choose m as the minimum of x and y, I reduced it from both of them. If x is greater than 0, that means it is a horizontal movement and y should be 0. So I swap x and y, and I swap a and b as well. Because like if we have a horizontal, if we have this horizontal movement with the cost a and b as given in the problem statement, this can be reduced as having a vertical movement with cost b and a. So I have swapped a and b as well. So this you can reduce from the problem statement. So I take like a transpose of the movement I have to do. So I swap x and y, a and b, and then this is the same formula we have figured it for. So this, like these are the values. So that is how I've solved problem E. Coming to problem F. Okay, so this was a good one. So now in this we are given a string S and this of uppercase English letters, and we have to uh, increase the frequency of ABC in S by exactly K. So if we see this example, here we have ATC ABC. So ABC already occurs once, but we want to increase it by one, so we want it twice. So we have this ABC. So we can make this ABC by changing this T to B. So this is one operation allowed to us, one replacement operation. And we have to tell the minimum number of replacement operations we require to make this our answer, to, to increase ABC by 1. So here it is 1. Here, if we see the length is 5, so ABC occurs once, and we need ABC to occur twice, which is not possible because we don't have enough characters. So here it answers -1, which means not possible. If we see this example, x a b c y z. So here ABC occurs once, but we want to happen it twice. So what we can do, we can choose this and this as the ABC. So here we will update all the 6 characters. We will kind of break this substring and create 2 new ones. So here in 6 operations we can get 2 substrings. So that is the idea. That is the problem statement. Now how to solve it? So I have solved it using DP. Honestly, my solution is pretty bad. To be honest, like if you know about push and pull DP, then in one state I'm pushing and in second state I'm pulling. So yeah, it's a little messy, but I can still explain the idea. It will be clear. So I have done like DP. Let me open this. DP of ij is the minimum number of operations to get j new subarrays using first I elements. J new subarrays, new is the keyword here because like we we have to increase the count by k. So yeah, and I cannot. I was initially thinking that I find the number of ABCs originally in S, then I do plus K and take that as a DP state. But here the number of already existing ABCs can be already very big, so we cannot have that as a DP state along with the string length. So I only take the new subarrays in first elements such that the jth new subarray ends at S of I minus 1. So this is a huge one. Like according to the state I have taken, if we take uh, something something a b c something, so here we have to do like 9 operations to create 3 new subarrays if k is 1. right? So I choose for each I, let's say I is here and j is 1. So I will have, uh, okay, let's say I is here and j is equal to 1. So want the I want j new substrings, like the number of substrings that already existed in this prefix plus 1. Like already one substring existed here. I want two of them, and the second one should end exactly at this point. That is my DP state. So the minimum number of operations are do that. And how the transition will look like. So if we are at some, like if we have some ABC already here and we are at this index, right? So let's say I have defined IJ. So I'm going to my implementation idea. So I have looped over I and J here. So for this I, first of all, I am breaking this subarray, right? And I is the index here till which we have to find the number of minimum number of operations, and J is the uh, like number of substrings we already had. So this is getting a little complicated. So don't take this dpij as one state. It is like if I choose these three this one, then in this portion I should have j new substrings. This is what I'm saying. I hope that makes sense. Yeah. So I have chosen I and j. Like in my I and j, they are defined such that if I choose a substring of length I, the first I characters, let's say, so the last ABC in my modified one in my final string should end at this index, and so this will be like ABC, and before this there should have been j new entries already. That is how I'm defining my DP state. Now what will happen is, since we are destroying this B, right, we are going to destroy this ABC, so the substring count will be reduced by 1, but here we are creating a new one, so this will be -1 and +1. So here we are going to maintain like j substrings only, j new entries only, if you notice. So that is the idea. So if we go to the implementation, I'll explain the why the segment tree. I'll explain it later. But yeah, uh, if the reason I have done that is, let's say we are A, B, C, something, something, and we are here. I is this, and this, and J is for this section, right? J new substrings are for this section. So if we do this A, B, C, this we are going to destroy this portion, right? So this will be like a -1 and this will be like a +1. So uh, in this case, dp, we for this j we will have a new j which is equal to j -1 +1 equal, which is equal to j only. But if we had a scenario, let's say xyz something something, and we were here, let's say here, so this is the substring, this we will update, and this is going to be, let's say j, or let's say this was a, so a z b, let's say. So we will make this ABC. For that we will have +2 operations, and now we will have a +1 new subarray, new substring, new ABC entry, right? So our nj is going to be j +1 in this case. The new j is going to be j +1 according to my implementation. So I will update dp of ij is equal to dp of I -3 j plus two operations. So this is dp of I and j. So this I'm going to assign it this way. So this seems a little complicated because of my implementation, but the idea is clear that I want this one to be a subarray. So before this they were j. So now we have j plus 1. If we just see here, they were in this subarray. I destroy one, I create one. So nj is going to be j here, and we show this from I minus 3 to j. Okay. I hope that is fine. But here is one catch, that this idea is not complete. Let's say this was not an inter this the substring we are updating, that was not part of an existing ABC. Then in that case, because our state is like the uh, if we see this state, this will store the substring. Uh, this will store a number of ways such that the jth new substring ends at index I minus 3. So it will expect an ABC here, this entry. So instead of that, we choose dp of 0j, dp of 1j, and so on till dp of I minus 3j. Like we choose the min of these, then we do plus 2 operations. I hope that makes sense. Why is that the case? Because if we have like a substring like this, a z b, and I is here, so we will make this ABC. But before that, we can have the previous substring could be ending at any point. It could have been here, like this could have been an um, a a existing before that, or something like that. Let's say this is an ABC. Before that, the previous ABC was here, ending here, or something. So choosing I minus 3, this is I minus 3, this is not enough. We have to find a maximum over all the values for this j. So for this, I have maintained a segment tree. So if we see that my dp dimension is n plus 1 times k plus 1. That is how vectors are defined in Rust. So it is n plus 1 times k plus 1. In my segment tree, I have done k plus 1 times n plus 1. So there are k plus 1 sectrees. So this for each j, I will maintain this segment tree and I find the minimum value. So that is the logic why I have written it this way. So this is a simple scenario when we are creating a new ABC. So there's no removal of existing ones. But if there is removal of existing ones, then things get pretty complicated. So if we have something like, uh, let's say A, B, C, A, B, C something, and we are at here. So we are going to destroy two substrings, right? So uh, here we are going to make it ABC. So this will be minus 1, this will be minus 1, this will be plus 1. I hope that makes sense. But but now, and we see from here. Now I have made a few claims here that if we are destroying this ABC, like we are destroying this ABC, then it means this one also this also went to an operation. The reason I'm saying that is, let's say we have something. If we have an ABC like this and ABC like this, now we want three values. So we have to go through it like this, right? But if we have like ABC, ABC, and four values, let's say, and we only want to, uh, let's say, increase it by one, then we need not update this. Just choosing these three values will be fine. So I have made a claim that if I am destroying a substring to create a new one, that means this also was updated to a substring like we this is also updated to a C here, and this is going to be in ABC here, because if not, then we need not create this. We could have just used this ABC directly. Since we can, I'm assuming since we cannot use this, we have to create this. That means an existing one is already here. I hope that makes sense. So the way I have handled it is, I'm here. So the number of operations is like 3 for this substring. Like to change the substring to ABC, we require 3 operations. How many? Now J will have -1 because of this. It will have -1 because of this, and it will have +1 because of this. I am going to claim that this plus -1 doesn't make sense, because this, when I was updating this ABC, I have already considered destroying this substring. So I will not consider it again. So this -1 comes from the father one, and this +1 is the new substring we have created. And this -1 is already considered in I-3 at dp I-3 something. I hope that makes sense. So now let's go to the implementation. Initially, I scanned through the entire string and labeled each ABC. So if it was something like A, B, C, D, A, B, A, B, C, D, E, let's say. So I labeled these positions as 1, uh, these as 2, and others as 0. Yeah. So I have labeled them to keep the track of the substrings, ABC occurrences. Now, going to the implementation, uh, for each I, let's say I am here, or no, let's say I am here, then I am going to care about these 3 entries, right? So I will take need the operations to make this ABC. So it is going to be +3 operations because all of them are different, and I will keep the track of which substrings I'm destroying. So like I'll push the occurrence which ABC instance I'm destroying, and this will keep a unique track of it. So the second one I'm going to destroy if I do this operation at I. How it helps us? Let me write it again. So if we were at ABC, ABC, and something something. So if we were at here, this was, let's say, the fourth instance. Let's say some ABCs were here before. This was the fourth instance. This is the fifth instance, or fifth occurrence of ABC. So I'll take this substring. It will require +3 ops, and I'm going to destroy 4 and fifth occurrence of the ABC. This is what I'm going to maintain. How will it help? As I mentioned here, that destroying the fourth occurrence is already considered when I did I-3. So I will do this. I will start with I-3. So if I-3, so here the occurrence array will have 4, 4, 4, 5, 5, 5. So if this 4 is considered in a destroy array, we will ignore it for now. We will only consider that we're destroying 5 for this I, for this I-3 in our transition. So you can see here I have created a loop let's say I prime, let's say from I-3 to 0 in reverse order. So that's what I'm checking. If the occurrence in this, let's say this fourth, is contained in an occurrence array. So that's what done. ABC occurrence of I, like this is 1 based indexing, so -1. If this 4 matches this 4, that means we have already destroyed this. We need not consider this again. That is why I have taken this length -1. Instead of two elements, we are only going to destroy one. We are going to remove one. Then it's the simple transition idea. We know J already. So Nj is going to be J -1 plus 1. Because -1 is from this. We will not consider 4. and then we have, and then the current value which we are going to update is like dp of I of j, so which is going to be I minus 3 for now, I minus 3 j, uh, it is like this, dp of I and j, we are going to update this with dp of I minus 3 j plus 3 operations. We find a minimum value of all of them, but this is what we are going to try to update. And if this current is greater than our current dp value, then we update it, and we update the same in the segment tree as well. So I hope this makes sense. So my implementation is a little bad, as I said, because for I am going for previous values. So this is kind of a pull idea. But for j, I'm finding a next j, which I'm going to update. So this is like a push idea. So yeah, the implementation is pretty bad, but I hope the idea is clear now. So if we have some occurrence still here, then we take this. Otherwise, we take the maximum for all the value for this j for all the values before I prime. I hope that makes sense. And then for the final answer, because now at we according to a DP state, our jth new jth new substring can occur at any instance. Like it can occur here also, here also. So we iterate over all the values and check dp of I k minimum of dp I k over all I, over all index, where we have get k new substrings, and then we print the answer accordingly. If it is infinite till the end, that means, like, since we have to print minimum operations, I initialize it with infinite. If it is infinite at end also, that means we cannot do it. So yeah, that is the idea of f. I hope that makes sense. It's a little confusing, but yeah. So that's it from my side. Thanks for watching. Bye.